Hello and welcome to today's Teardown Sessions from Crowd I am your host, Helen Leigh, and we've got a really exciting stream coming up for you today. We have got Alicia Gibb from the Open Source Hardware Association and Javier Serrano from CERN. So we're going to talk to them about open hardware and open science and all sorts of exciting things. But before we jump into that, I'm going to give you a quick update on what is happening in the world of crowd supply. All right, so we've got a new launch, which is going a bit gangbusters at the moment. We've got the Kraken SDR, which is a phase coherent software-defined radio. That's been going about just over a day and a half, and it's raised 136K. So lots of exciting developments there in the world of open source software-defined radio. So check that out. Also new in software-defined radios, we've got an ATEC 1001, which is a pre-selector for SDR, so check that out. We also have a new fingerprint sensor with optional NFC, so that's also existing. Ending up, we've got the coupled tag. We've got which is a tap-to-read NFC tag, which is a super low power and a pretty exciting little piece of technology. Coming towards the end of its campaign, we've got the Home Assistant Amber, which is a fantastic piece of hardware. If any of you are into home automation, but you want to do it with security and privacy, you should definitely check out this campaign. Very exciting things. If you want to keep up to date with crowd supply in general, we've got a newsletter which goes out every week, so you can subscribe to that. And I also wanted to give a quick shout out to our field reports program, which is a great program. If you've ever used a crowd supply piece of gear, you get $25 back if you tell us how you've used it and show us some pictures of that. So I do look forward to seeing some field reports from some of you. All right, that's a quick roundup from us here at Crowd Supply. So without further ado, I'm going to add in Alicia Gibb, hello, and Javier Serrano. Let's unmute your mics. That mic check. Here we go. Well, hello. First of all, before we get started, I did have one more thing to say, which I forgot to do during the intro, is we have a giveaway. We have every stream we do, we have a hardware giveaway with open hardware and open hardware swag that comes in one of our limited edition Crowd Supply lunch boxes. So what I do is I write a timestamp on a piece of paper, and the person that comments closest to the timestamp will get this. Wherever you are in the world, there's a box of surprise mystery hardware goodies in there for you. Okay, so while we're going to kick off with Javier and Alicia right now, but first of all, I'm going to say hello to some of the people who are joining us on the stream. Please do keep us company while we're chatting. We do like to have people saying hi to us. We've got Drew Festini here with us in the house saying they're looking forward to the stream. And also Brittany, who's in the house, saying hi to us. Hello, both of you. Hi, both of you. So let's kick off. Do you want to introduce yourself? Who goes first? You're the one on the top from me, Alicia. So why don't you introduce yourself and tell us a little bit about what you're up to?
Sure. My name is Alicia Gibb, and I am the Executive Director and founder of the Open Source Hardware Association. And so I basically live and breathe open hardware. I try to, coalesce our community around some standards. We've done a lot of work in best practices for open hardware. And we just kind of try to, in addition to hosting our annual summit, we kind of try to have the community be able to talk to each other through our various platforms throughout the year as well. So that is more or less what I'm doing, and some side tinkering as always when I get time.
Amazing. And how about you, Javier? You're working at CERN, aren't you?
Yes, I'm working at CERN, the European Laboratory for Particle Physics. I lead a section of developers of hardware and low-level software, and we do controls and data acquisition for particle accelerators. And we've been doing open hardware for many years now, for more than 10 years. We started by creating the Open Hardware Repository, which is a place on the web to collaborate and to share hardware designs, especially for people who are in our community of high energy physics or big physics facilities. We also drafted the CERN Open Hardware License, which is something that allows people to share hardware efficiently and on a sound legal basis. We've been contributing to KiCad development for a number of years, so that's something that's also very important for us. And I'm very close to several groups. I'm in the board of the OSHWA. I'm also very close to the GOSH people and to the FOSSI Foundation, to the Free and Open Source Silicon Foundation, which are more into things like FPGAs and ASIC design. So very happy to be here.
And I'm going to be asking you questions later about the open FPGA guidelines that you've been publishing. A lot of our viewers are really into FPGAs as well, so I'm really interested to hear more about that. So let's kick off here. So open source hardware is a term that gets bandied about quite a lot, and I see people using open hardware for things from just publishing their schematics down to people with full certification who are using KiCad and all the open source tools. So what actually counts as open hardware? You know, like there's so many different definitions of open hardware. I mean, OSHWA has its own definition, of course, but what would you consider the difference between the general concept of open hardware versus the OSHWA version of open hardware?
So I actually think they're more or less all the same. Basically, what open hardware means on a very basic level is just hardware that has enough source put out that somebody can copy it. And so if you've put out enough source, or if you've had your hardware, you know, copied or had a derivative created of it, you've done your job. You've put out enough source that is completely okay, and that's open source hardware in a nutshell. I think there are, you know, we have our certification, which just is basically that same concept, but just like, hey, we've double checked that you did it all right, and so then our community can know for certain that they can find the design files, that there is, you know, a sort of a governing body that's saying, yes, we agree, this is open hardware. And that also lets the creator know that they have some validity in saying, like, yes, this is open source hardware. They know that they have, you know, sort of done it right. But yeah, it's really just sort of, you know, putting enough source files out there so that other people can recreate what you've made.
What does that actually look like in practice? What's best practice for? Say I created a board and I wanted to make sure that it was open source and fully able for other people to remix. What are the best practices for me getting my hardware out there?
Yeah, so I think one thing that's tricky about hardware is we consider, you know, hardware anything that's got atoms rather than bits. And so that's everything from, you know, ceramics to electronics to 3D printing to, you know, various random things built for space, like, you know, DIY bio stuff, like dealing with liquids and things, like what's the source for a liquid, right? So it really depends on what your hardware is. But to give you an example, so for like a piece of electronics, we would say, you know, it's best practice to release the schematics and the board file. And with those things, it depends on how complex your board is as well. But for like a 2-layer board, that is probably enough that somebody could, like, you know, do create their own copy and do what they want with that source to really, you know, create something off of what you've done. If it's, you know, something that's much more in depth than that, 12-layer board or whatever, there might be Gerbers alongside of it that you need to release so that it's truly open source.
And what about, so something that I hear a lot in terms of best practice in the open hardware circles is there's lots of people who are advocating for the use of FOSS software in the creation of hardware tools. And I think that's a growing trend. I see more and more people using things like FreeCAD, things like KiCad. KiCad, not KiCad, right? They're French, so it's KiCad.
There's two schools of thought on that. There's
but one's right.
Yes, I go with Jean-Pierre, with the creator of KiCad. Yes,
I agree.
I go with the way he pronounces it. Yes.
Yeah, I agree. I think there's no French person in the world would say Kai.
No.
No.
It's a very nice story for those who don't know. Jean-Pierre was a teacher, a professor of electronics, and he wanted to give his students a tool that they could take home and they could practice with. And he also wanted to learn C++. So he put the two things together and he started developing KiCad a long time ago. Since then, many professional computer scientists and people who do programming for a living have joined, and the quality of the code is much better these days. And it's an important thing, as you say. In my opinion, there is sometimes not enough stress put on this. This is, when you think about the world of Office suites, for example, you have a proprietary de facto standard, Microsoft Office, right? And if you put a docx file out there, you know it's proprietary, but you know that more or less, people will be able to open it and edit it and get your content in some kind of way. First of all, because many people own that software, and others have software that can read that format more or less appropriately. In the world of PCB design, there are several major players with more equal splits of the market. So there are many chances that if you use a proprietary tool and you release your design files with that tool, the person who receives those design files will not have a license for the piece of software you use. So, and then we go back to this definition of open hardware. It's supposed to give you these freedoms to inspect, to change, to republish, etc. And those things, even if you have the right as per the license, you might not have the possibility just because you don't have the tool to read that. And I want to stress also that, some people say it's fine, and of course everything is fine, but some people say that something that doesn't have any cost is okay. Well, it doesn't have any cost today, but you don't have any guarantee that you will be able to access it in the future. So there is this very important distinction between something that's free as in pre-beer and something that's free as in and freedom. So we keep saying these things over and over, but I think it's important. So in KiCad and in other software tools like in JEDA and other PCB design tools, your designs are text files which you can even read and modify by hand if you want with a text editor. I wouldn't recommend that for the complex designs, but you can do that. You can write your own parsers. You can write your own tools to extract, bill of materials, for example. Before we were talking about the files that you need to expose. I think bill of materials is definitely one of them. And you can do all sorts of automation on your own, and you can contribute it to the tools themselves. So yes, in my opinion, very important. And it's also important that people contribute to these tools. And this is something that, sorry, I'm being a bit long here, but
no, it's really, please carry on. It's really interesting.
This is something where we hardware people are at a disadvantage with the open source software people, because they had an itch to scratch, and they had the talent they need to scratch it, right? If you're a developer and you want a compiler, which is open source, you can write a compiler because you're a developer. You have the talent that you need. You have the skill that you need to do that. If you're a hardware developer, it's not a given that you can program. And I take programming very seriously because I work with a lot of professional programmers, and it's not easy. Everybody can write a few lines of code, but doing it right and maintainable and scalable is not easy. So yes, I invite everybody to consider going. Those of you who are doing open hardware already, consider taking a step, one more step, and try to help with the tools.
Yeah, I mean, that's a really good point. And I would also stress that, KiCad is getting a lot better now. Like, these open source tools are getting considerably better, in part, actually, because CERN, which Javier works for, has been investing quite a lot. What has that, you've got, what is it, 2 full-time? What does CERN do for KiCad?
That was in the past. In the past, we had one full-time person also with there's a KT fund. KT stands for Knowledge Transfer at CERN. It's the group. In other places, it's called Tech Transfer, and it's the group that coordinates our the impact of our technologies outside, and also technologies that we use from outside, and sometimes they fund work for things that we want to have an impact outside of CERN. And they funded one full-time equivalent for a couple of years. That person was supervised by one of my colleagues, by Tomasz Wostowski, who was also very productively working in his spare time to also complement the efforts of Orson, who was the person hired. And they did some amazing things. You were talking about the improvements. I think there is one key development that I like really a lot that took KiCad to another league, which is the push and shove router or router. I think the Brits, they say router, and the Americans, they say router. So, you know, this notion that when you start pushing a trace and the others make space for you while still respecting the design rules. So that there's a lot of computation and geometry in there, and kind of the high-end tools had that, and KiCad didn't have it. So Tom, my colleague, contributed that. So nowadays, both Orson and Tom have other projects at CERN, and what we are doing is, in collaboration with the CERN and Society Foundation, we raise money, and we subcontract work to the lead developers mostly. So we identify work packages, we follow up, and we make sure the money is invested in making KiCad better. So we put that in place a number of years ago. Now there's also a Linux Foundation way of donating to KiCad. So there are two ways. And you know, I invite people to use either of them. And
well, if anybody if anybody wants to donate to those, for those of you watching the stream, after the stream goes out, I will put the links at the bottom for donation to either of those places. And thank you for giving that a shout out. I was going to say, like, for those of you who want to use open source software to create open source hardware, but are not as skilled at software, perhaps, and you can't contribute in terms of code, there are ways of you donating to make that possibility a reality. But I would say, if it's been a few years since you've tried KiCad, I would recommend you download it again, give it another try. It's much better than it used to be. It's definitely workable. I've got some questions here from people in the stream. So Improvised Dynamics, hello. Is it still open source if it uses proprietary OTS components? And Brittany from Great Scott Gadgets has said, what does OTS stand for? And that's off the shelf, for those that don't know. So there's a question there. So is it open source if it uses proprietary off the shelf components? So that might be a question for you, Alicia.
Sure. So the answer kind of depends on who owns those components. So if you own those components and you've decided to close those components down, lock them down, and create a project with those components, then it would not be considered open source. So that's kind of one example of, you know, when it would not be open source. If it's a complete third party, you know, say it's a chip or something that you're using, right? And or, you know, or even like a resistor or a diode, something, you know, that mundane. If it's a third party component and you put it in your design and like you have no control over the IP of that component, it's considered open source, as long as other people can, you know, get a data sheet easily, you know, that's publicly available, or would be able to get the part as well. So for example, I don't always like to, you know, pick on particular pieces of hardware or anything, but yeah, Helen.
Yeah, I know where you're going. Yeah, I'm just agreeing with you.
Okay. Yeah. So one of the pieces I think that's often sort of misconceived as an open source hardware, but is not because of this exact sort of rule about it, is the Raspberry Pi. So Raspberry Pi uses the Qualcomm chip, which is the data sheet is not publicly available, and the average person cannot get those parts. And so for those two reasons, you know, that would be, for example, a piece of closed source hardware.
But Raspberry Pi is not open source to begin with, right? Anyway.
No, they do not ever state that they're open source. They don't try to be open source. For whatever reason, though, the community loves to confuse that as an open source piece of hardware. Yeah. But like, then you look at, like, for example, then the Arduino, right? Like the Atmel chip is very easy to get a data sheet of, very easy to buy those on your own. So Arduino, for example, is considered open source.
Yes.
Drew just piped up saying also the full schematics and board layer are not shared either. That's true.
Yes, which is some basic thing you would expect of an open source hardware project. Regarding this question, I also wanted to chip in. We gave a lot of thought to these proprietary off-the-shelf components, of course, when we were drafting the CERN Open Hardware License. In particular, when you draft the reciprocal variants, the ones that would be called copyleft in the software world, it's very important to define the scope of the obligations when you share back, right? So zooming in to the PCB, you arrive at the resistor, for example, and you want to make sure that people don't have to share the recipe to make a resistor; they just buy it, right? So we define the concept of available component, which is kind of translating this common sense notion that that's the way people work. If you have a resistor, you just buy it. So anything you can buy, anything that you can get, including if it's proprietary and if you have to pay for it, that's okay. It should just be available to anybody. And any component that does not invalidate the open sourcedness of the PCB. Now, moving up, there's also sorry, you wanted to say?
Oh, there's another piece here from another comment here from Brittany from Great Scott Gadgets saying that they've got a lot of open source hardware, but they use a lot of proprietary off-the-shelf components. It would be great if there are open alternatives, though. So kind of before you zoom back up out of the component level, I wondered if you might address that that idea that people are, are there people starting to create open source alternatives all the way down? I mean, obviously, we know that people are starting to create open source silicon from the Google Skywalker project. But is this something that you've seen anything of as well? The idea of open source off-the-shelf components.
I mean, we still have a long way to go on a lot of things, right? And it also determines, there's one side which is just electronics, and then there's all the other various open hardware in the world, and what do all those fields mean for their source to be truly open? There's also this concept of oh my gosh, where does openness stop? We could go all the way into okay, where are you mining your copper for this? Is that part of the source, or is that just too much or whatever? And I think that as the community grows and sort of as we kind of figure out what the alternatives are, and as the alternatives grow, I think then we can start having different conversations around okay, what's next for true openness. But currently, I think we're in this phase of there's still not enough things that are open source fully that we are able to just be oh, great, all the components exist, they're super easy to get, we'll just do that, that's my answer for that question.
Yeah, that's super interesting. And I have seen a lot of people, I'm on the mailing list for, there's a cable, a USB cable that is trying to make their entire supply chain transparent, which is an interesting, they're just starting with one cable. And I just think that's really interesting. And of course, we've got people like Fairphone who are trying to address those kind of issues in electronics. So it's interesting to see those people kind of come together, right? I think that's something that I really wanted to chat about with you while I have you both on the stream, is this concept of open hardware, how it fits in with the broader idea of open. I've come from many, I've met many people who are active in open science, open government, open data, all of these different people who are pushing for openness. And I was wondering how open hardware fits in with the larger scale push towards openness in our society. If you think it does, in fact, or if you think I'm just wishful thinking here, thinking that there's a push towards openness. I'd love to hear your thoughts on that.
I absolutely, I think we're like a giant player in that whole ecosystem, right? You gave the example of Fairphone, which is a great example. And when you look at our phones and you look at just the hardware alone and what can happen based on who owns that hardware, what happens with your data based on who owns that hardware, when that's not transparent and open source, and how you can fix it and who's allowed to fix it, and all these kinds of things, which by the way, I just want to put in speaking of other movements that are kind of tangential, the right to repair movement is a huge movement that's tangential to open hardware, right? And so of course we want to be able to be transparent enough with their designs that other people could fix it. That's just mind-blowing sometimes. Like, you can't fix your own hardware, what? And there's actually there's legislation in the United States Congress currently on right to repair, so that's super exciting, at least for us over here. So
that's interesting. And
Also,
how about you, Javier?
Yeah, regarding open science, I think the fit is very natural. I know at CERN we are, of course, a scientific institution, and we have a mandate to share the scientific results, but also to share what we do in the journey towards those results as much as possible.
Yeah.
And there are different opens inside CERN, and we're gathering them together under the banner of open science. There's open data for people who want to reproduce your results. There's open publications, open access, so that people don't have to pay to read your articles. That, you know, everything is free, and the curating and the editing is done by the community, or paid in any case by the providers or by the producers of information. So it's kind of turning the market upside down. There is open source software, of course, an open source software, and there is hardware. And I see not much difference conceptually between software and hardware. And in many domains, the line is very blurred already. So in the end, you have sources. They can be schematics. They can be things you type, like code. And then there's a product. It could be an executable, or it could be a piece of hardware. So there is conceptually not that big of a difference, and that's why I'm very excited that there's already at least one country, France, where they just published an open science policy that includes and takes very seriously open source software, the software that you develop you know, when you do research. And it says that it's very important that you don't only publish your data and your publications in an open way, but also your software. And I see there's not a big step from software to hardware. So I have high hopes that you know, countries start bringing up the hardware side as well when they talk about open science.
And I just want to give
go
I was going to give it a shout out to Gosh, the Gathering for Open Science Hardware. You know, so that's a group that's just focused on science and scientists and making sure that their hardware is open. And, you know, when I've been in discussions about open science hardware, that's one of the things that always strikes me is, can it really be science if it's closed? If you cannot reproduce the, you know, the machine to collect the data, or if you can't reproduce the hardware of like how it all got to be, you know, these results and this hypothesis, and like, you know, then like if you can't reproduce it, that's one of the things about science is you have to be able to reproduce it. So I don't understand how closed source can play with the science field, really. You know, I mean, I think open hardware and openness in general is just such a key component to science. So I love that they're pushing that field forward with openness.
I mean, and also I think that push forward into greater openness in science has been born partially of a number of scandals where people have lied about their results and haven't been, because they're trusted names in the science community, they haven't been subjected to the rigors that they would have done if their results and methodology were publicly available. So I think it's good to have that scrutiny as well. I have a question here from Brittany saying, does CERN avoid publishing in journals that are not open access? Now that's a really interesting question, because journals are still extremely closed. So what kind of steps have been taken towards making sure that the information that you're gathering is open?
Well, CERN, you know, most of the publications at CERN are in the high energy physics domain, and high energy physics has for a long time been open access already.
Really?
And there have been and I think it's more than 99% of the content of, you know, publications worldwide for high energy physics are open access, and they have been for a number of years already. What CERN has done in addition to that is that they have this consortium, Scope 3 is the name, and what they do is they team up with other similar institutions worldwide, and they say, okay, I'm not a specialist on this. I apologize if there is an expert on open access, but and I'm saying something wrong. But my understanding of it is that they say, okay, we're going to produce, you know, X thousands of papers this year. Who wants to publish them? Who wants to edit them? They do some kind of call for tender, and the condition is upfront from the beginning that it shall be open access. So they get prices from the editors, and then they choose one based on the price, the quality, and other things. But it's from the outset understood that it will be open access. So this is one way that CERN is practicing open access. I also wanted to say that something about the previous subject, but it slipped my mind. Sorry. Say something, and
It's
I will.
okay. It'll come back, I'm sure.
I will just also give a shout out. I do happen to be a board member of these 3 journals, but there are 3 journals also doing specifically open hardware: the Journal of Open Hardware, the Journal of Open Engineering, and Hardware X, and they're all trying to do kind of open access.
I remembered.
Oh yeah, go ahead.
Yes.
Go.
So yes, about the fundamental role of open hardware and open software in science. I think in the end, it's not absolutely fundamental because Mother Nature will hit you. If you you cannot fool nature, right? In the end, it will get known that your result is not reproducible. It's just that there is so much inertia and so much friction that you could avoid by opening up things, and you can basically make a big difference if you allow people to reproduce your designs or your results in an easy way. So I think it's not strictly speaking fundamental, and there has been a lot of science up to now with proprietary software, with proprietary hardware, but it just makes things so much easier and it reduces friction. So I like this notion that open source reduces friction.
Yeah, it's true. And I think it's especially with publicly funded science, it just absolutely makes sense, so you're not reinventing the wheel constantly. I always love it when we get we've got a few open science hardware projects on the go at the moment with CrowdSupply, and I always really like seeing that because it's just, it's such a great resource to future academics as well to be able to build on other people's work. Yeah. I wanted to ask about developments internationally in open source hardware. I think it's something that's really, it's really, I mean, we've got, a European, a British person and an American in this chat, but it's really not, it's not there. There's like really, really big communities in Latin America for GOSH in particular, I know, and various other places in the world as well. I was wondering if you might give us a kind of update or some shout outs to people who are living in other parts of the world who are doing some really, really cool work that we can look up to and take some lessons from.
Yeah, so I think I continue to get more and more excited that we seem to be growing our board at OSHWA more international with nearly every election, it feels like.
That's great.
So yeah. So we've got, we've got Javier on our board now. We've also got Toby from Nigeria, and we've got Salman from India. And so they're all kind of, it's really fantastic because they can basically tell us like, hey, like this is what OSHWA should be doing, for this particular section of the world. And I feel like it just kind of like makes us all more equitable, and like we want to be able to be there for everyone. We do have a branches program, so anybody can create like an OSHWA branch. And we've had the most success with these in Latin America, certainly in Central America. And so there have been branches created in like El Salvador and Ecuador and Mexico. And so, it's sort of, but it is a difficult thing to keep up. And so the branches do kind of ebb and flow, and sometimes are there and sometimes aren't there and things like that. Because it is all on a, we're all on a volunteer basis. So, yeah, it just kind of depends, where people are in the world. We obviously want to hear your thoughts and how we can, do open source hardware together. But definitely, I think you're right. There's like, obviously, areas that we just don't know about. And we're trying to learn about them.
Yeah,
certainly.
I would say that I'm getting it's from Crowd Supply's perspective. Obviously, we get submissions, so we only do crowdfunding for open source hardware. Not all of them are OSHWA-certified. Some of them are sharing, schematics and firmware, which is our basic level. We do encourage people to go one step further with their openness than they came to us with. But we are noticing. We've always had quite an international range of creators, but I would say in my own experience, we're getting more and more open hardware from India all the time, like constantly.
Yes.
So I was wondering if that matched up with your experiences.
Absolutely.
It seems, like, and the quality is excellent, and we're getting these really enthusiastic young creators through as well, which is really wonderful to see. But yeah, I was wondering if that matched up with your experiences.
So for all of our open hardware summits, we have the Ada Lovelace Fellowship, which has been running since 2013.
Oh, isn't that open now as well, by the way?
It is open right now, yes.
Yeah.
Shameless plug for the Open Hardware Summit and the Ada Lovelace Fellowship. Yes, so the Ada Lovelace Fellowship is for marginalized populations in tech. And by the way, the submissions call is also open, so if you want to speak at the summit, you can go apply now. But yeah, so the Ada Lovelace Fellowship, we've always had a broad spectrum of people apply, but this year in particular, I don't have like a percentage off the top of my head, but I want to say it was somewhere probably around like 70 to 80% were all people from India.
I think there is a trend.
Huge trend.
That's great. That's great. That's really great. Lots of really interesting technical people coming out of India at the moment. Very, very exciting. Yeah, here we are. Look, there we go, Drew. There's an Ada Lovelace Fellowship for the Open Hardware Summit 2022 in NYC on April 22nd, answering the question I was just about to ask you. When is the summit?
Yes,
and like,
fingers crossed.
Let's rewind a little bit here and say, what is the summit? Because we didn't actually cover this.
So the Open Hardware Summit is OSHWA's annual conference, and we talk about all things open hardware. So usually there's talks on open hardware in education, in science, some legal stuff, policy stuff dealing with open source hardware, of course, manufacturing, engineering, just the basics of what open hardware even is. Lots of like artists as well, and any field is welcome. We want to hear about all different fields that open source hardware plays in. And all types of people are encouraged to apply as well.
Yeah. Oh, and also here we have that Leigh Borg is the chair for the summit. Yes. Oh, brilliant.
Shout out to Leigh.
Leigh is awesome. Excellent. They are. I own all of Leigh's zines on electronics. I'm a big fan of Leigh's work. Good job. Well done for employing Leigh. That's a great job.
Yeah.
So, but correct me if I'm wrong here, but the Open Source Hardware Summit, did that precede OSHWA as an organization?
Correct.
So who founded the Open Source Hardware Summit?
So
that was the first one, right?
Yeah. So I founded that along with Aya Badir. So
Aya Badir, she's awesome.
Yeah. So we were in New York City, and I was working at Bug Labs, and at the time, my boss was kind of saying like, "Hey, we have all these like problems in open hardware, and what does it mean?" And I mean, this was like, I think this is going to be our 13th summit, so this was, like over a decade ago now. And this was before the open hardware definition was written and all that kind of stuff. And so we, and at the time, like Aya was doing an open hardware workshop through iBeam. And so like I connected with her there and was like, do you want to do something bigger? And like, let's take this, on the road. Right. And so we ended up joining forces and creating the first Open Hardware Summit. And it kind of ran under the Bug Labs purview for the first 2 years. But then it was clear that like, okay, like it's super weird for like other companies to kind of like be paying this company for the summit to like sponsor through there. And then like we had like our hosting, our domain was owned by like one company, our hosting was owned by another company. And it was very clear that like, if any one of these startups like went under, like we'd be like out our hosting or the URL or whatever. So we ended up, I ended up creating the nonprofit OSHWA, basically just to house the summit. And that was like sort of all it was supposed to do. And then like, oops, we grew. So, you know, we realized very quickly, I think, that there was a lot of desires in the open hardware community, a lot of, you know, explanations to get through, a lot of best practices to write, and all that kind of stuff. So we ended up housing like the Open Hardware Summit, and having like a real financial, you know, thing to put that umbrella under. And then we also housed the community's definition of what open source hardware is, which is, you know, what the OSHWA definition is really the community's definition. And we're just the stewards of that definition and put that out into, you know, the world and amplify that. And then we wrote best practices after that and have, you know, done a number of things for the open hardware community ever since.
I'm just about to bring up the link to. So Brittany asked, is there a link to share for the Ada Lovelace Fellowship? And here it is. So if you're interested in applying, it's in the chat, but it's also in the comments there. All right,
awesome.
Cool.
Thank you.
Don't forget to keep your questions coming for open source hardware. If there are any things, let's see if I've actually missed anything here. We've got the open source software questions, and then we've got, okay, thank you, Brittany. Brittany says, thank you, I'll share that link around. Thanks, awesome. Brittany. Oh, and fun fact, the photograph on that page, which is this page, was taken at the Crystal Ballroom in Portland during Open Hardware Summit 2017. I wasn't in the country at that point. That's cool. Thank you.
Yeah, thanks, you know, the fun part about that was that wasn't even people like who that wasn't actual Ada Lovelace fellows, but it did happen to be just the last people who were in the room at the Open Hardware Summit. And we were like, hey, everybody who's left, like, come over here and we're all going to take a photo. And so we did. And I continuously look back on that photo with a sense of pride as to the diversity of our community makeup, right? It wasn't like a specific subset of people that I, you know, was particularly trying to get. It was just like, hey, if you're still in the room, like, come over here and we're going to take a photo. And that's who shows up at our summit, and that's who we represent. So it makes me really happy.
Yeah, that's exciting. I wanted to ask what the future plans were for, so obviously, you know, this year's been a fairly busy year. You've got, what did OSHWA do this year? Because I'd like one of you to talk a little bit about the FPGA guidelines, if you wouldn't mind indulging us, because I think that's pretty exciting.
Javier, go ahead with that.
Yes, so you know, FPGA is this hybrid domain, which is kind of at the border between hardware and software. When you describe a circuit using a hardware description language, you're really describing, yes, things that happen concurrently. So you're not, when you're programming, things happen sequentially one after another. But it is true that even if it's different, it's still code. And for a number of years, even before the officialization of the notion of hardware, or open hardware, people were already sharing FPGA designs, were already sharing VHDL and Verilog, because it made a lot of sense to take the files and do with them the same thing that people were doing with C and C++ and other programming languages. So they were putting these things in repositories. At the time, I think at the end of the 90s, there was the opencourse.org was the place to go for these cores, these HDL cores. But there was a very uneven level of quality. Sometimes things were not released properly. Sometimes no test benches. You know, verification is very important in FPGA design. You don't really release a design without any test benches, something to exercise it and to test that things are working correctly. So that's one stream, if you want, of FPGA design. And then the other stream comes from open source hardware enthusiasts who are discovering FPGAs now, right? People who were playing with Arduino, and they want to do something. They have applications in which they need more speed or more performance, more determinism, and they want to do things in hardware or maybe just for fun. There are also heroic efforts to do free and open source EDA tools for FPGA design. Some really impressive stuff of people reverse engineering the bit streams, the configuration bit streams of the FPGAs, and designing synthesis tools and place and route tools and so on. So we have those two communities, and we thought they could both benefit from some guidelines of what you would expect as a recipient of those designs, to be able to do the things we were talking about before: copying, modifying, reproducing the work, improving it, and publishing the modification, and so on and so forth. So we published these guidelines. They start with a bit of an introduction for newbies. There are also some words that we like to use, like gateware, instead of firmware, which is sometimes used. So to make a distinction between the HCL code and whatever software you might be running inside, for example, a soft processor inside your FPGA. So then we go on to describe the files that we would expect to be shared, which goes beyond the design. So there are these ancillary files like test benches, but not only, scripts to generate, net lists, and from there the place and route process and so on. And then we talk about licensing, which I think is important because, as I said, the opencourse.org community, they were people kind of adopting software practices, and they also adopted the licenses from the software world. And some of them, in particular the reciprocal ones, do not work perfectly well for HCL designs. So we also give some advice of the type of licenses that you might want to use, without any prejudgment on the sharing regime that you would like to use. So there are these three families of licenses: permissive, weakly reciprocal, and strongly reciprocal. And we provide options for the three types of sharing that you might want in your community.
Very cool. I have a question here from Brittany about FPGAs, asking what's the next big thing for FPGA development in terms of open FPGAs, I'm assuming here. Like what are the big tasks that people are working on?
Okay, so I think in terms of my ability to share my work at CERN with the rest of the world, one big pain point is the absence of good mixed language simulation tools, which are free and open source. So there are people working on that with System Verilog support. I know there is a company called Ant Micro and collaborating with Google on the good System Verilog support. So those are very promising efforts. They are also working on openly documented file formats for every stage of the way. There's a tool chain for FPGAs that starts with your synthesis. So you write a description of a circuit. The synthesis tool kind of interprets the circuit you want in terms of gates and flip-flops and other components, and spits out the netlist. And then from the netlist, you do the place and route. That means that this place and route process has to know the chip you're targeting. So what are the configurable logic blocks that you have? What is the interconnect that you have? So it maps your netlist into geographically different areas of your circuit. And one effort these people are doing is introducing file formats for netlist, for place and routed, every step of the way. And that is a very important effort, because that will allow people to mix and match different tools. You will have the possibility to choose your synthesis tool, to choose your place and route tool independently, and there will be a way for different open source efforts to emerge, right? Also, the other thing that's happening in FPGA is that there are vendors now willing to share enough detail of the internals of their chips so that people can write these synthesis tools, and that's also very nice. So I know there is one vendor, I don't remember exactly, maybe Drew knows, but I know there is one vendor already relying completely on open source tools for their IDE, and there are other vendors considering opening up more and more. So that's also very promising in the world of FPGA. And then something that would be really cool is that if somebody could provide an FPGA chip which is itself open source, because FPGAs are reconfigurable, and what we're discussing about here is how you configure them with these hardware description languages and how to share that hardware description language design that's going to configure your FPGA. But the FPGA to begin with is a piece of silicon that was designed like any application-specific integrated circuit, or so that design could also be open source. And if it were open source, then by definition, people would have all the information they need to write the tool chain. So I know there are some efforts underway, and I'm very excited about this. And yes, Drew says it's quick logic. Sorry.
Drew says, yeah, Drew, that's fine. I was about to bring that up after you finish your sentence. So Drew says quick logic is the one that's totally open source for the vendor, but also that Lattice is starting to embrace what the community has done. I also have a question here from Leon and Navi saying, do you know what percentage of the OSHWA-certified open source hardware has been designed with KiCad? That's an interesting question.
That's a great question.
And another thing from Drew saying, Quick Logic did the quick feather on crowd supply. That is true. They did do that. But yes, so that's interesting. So I am seeing more and more. Actually, we've got a tag on crowd supply. I can't remember what percentage it is, but we know what percentage. I can look it up. We've tweeted it before that actually an increasing percentage of the open source hardware on crowd supply is now designed with KiCad, including some of our biggest projects from the last year. And Watchy, for example, all of Leon. So Leon is a creator of ours who does all sorts of open source hardware based in Bulgaria, and you, I think you use KiCad all the time. I'm pretty sure Leon confirmed that there. But yeah, I'd be interested to do you collect that kind of information? Do you know that, or?
We don't collect that information. That would be interesting, though. But my sense from our community is that just like crowd supply, more and more people are using it.
Yeah, for sure. And a quick thank you there from Brittany saying that I heard this stuff on Lattice, but not Quick Logic. Thank you. Well, thank you. Also, it's my timestamp came up. And the closest, my pre-written timestamp, and the closest person to comment next to it was Brittany. So Brittany, if you DM me your details on Twitter, I will get this box of mystery hardware sent out to you, which I don't even know what's inside it. Oh my goodness. It's a Quick Logic development board. Look at that. This has turned into the Quick Logic stream. So you get a Quick Logic development board, a USB to TTL serial connector from Adafruit, loads of nice little stickers and swag, and a laser cut crowd supply coaster as well. So Brittany, if you drop your address to me in a DM on Twitter, I'll make sure that goes out to you next week. So there you go. Thank you. Okay, that's that's the little thing down there, and you get the cute little box too. From Teardown 2019. So that's going to be fun. All right. So we're actually drawing, we've got about eight or 9 minutes left of our stream. So I wanted to throw it over to the guest. Was there anything that either of you wanted to tell our engineers and creators about things that you would like help with, things that, creators that should be celebrated, any things that you want to share with our audience here on the Teardown sessions? Oh, we've got something from Drew actually. Drew says the tipping point posted on June 18, 2020 by Brain Faith is a good read. I'm assuming that is an article there. I haven't actually read that myself. I'm seeing a big, lots of nods there from Javier. But yes, here we are. So it talks about how Quick Logic decided to use the open source tool chain. There we are. So that's a good recommendation for a reading point, and I'll post a link to that for those of you who aren't watching at the same time as we streamed this. I will post a link to that in the comments as well, in the description, the video description. All right, cool. And you're welcome, Brittany. There we are. Thank you. So anything that you want to give shout out to, or ask for help on, or just generally, chat about.
I just wanted to let people know that on the OSHWA website, which is oshwa.org, you can find a tab of resources where you can go and look at all the different resources that we have for developing open source hardware. There's a checklist that like you can just go through the checklist and say like, oh yes, okay, great. I've given my permissions. I've released all the source. Like I can call this open source hardware or whatnot. And then there's also, I'm going to share my screen here, the State of Open Hardware 2021 that we produced this year. And so this is a really great kind of state of the open hardware community, the projects
oh yes, we saw
that
this.
are part of it, the various fields. It's got lots of metrics for growth. That's one of the things that we're trying to do is collect metrics about the community. It's got countries and then it's got like the people behind open source hardware. So it talks about myself and Aya as starting the summit, and then the Ada Lovelace Fellowship, which is funded by Addie Wagon Connect, and all our summit chairs and our board members. And then it's got like a community survey that we did also at the end. And so if you're curious, like how many people are using open hardware, what are they using it for, all those kind of things, there's some metrics there, and then a list of all the various partners and kind of people within the open hardware universe at the bottom. So it's just kind of a quick snapshot of the community that we produced this year.
That's really awesome. And is there a link to the summit from that site as well?
Yes, there is. Yeah.
Okay,
there's a link to the summit and to the certification page. And it's October, which is Open Hardware Month. So happy Open Hardware Month, everybody.
Oh, yeah. Of course it
so
is.
yeah, so everybody, there's all kinds of ways to get involved with OSHWA through our summit, by certifying, and also by becoming a member. And the members get to vote on our board. So you become a member, there's that perk as well.
That's exciting. All right, cool. I'm a member of OSHWA, actually. I just remembered that.
Yay,
you say like, there we go. Yeah, of course. So anything that you wanted to shout out to Javier in terms of things people can donate to, things people can contribute to, things people can read, anything exciting like that?
Mm-hmm. Okay, I see a couple of areas where people can help. I already talked about the tools, and I think not all the tools in all the domains are as well served as KiCad. So please consider other domains of open hardware like mechanical design, and also the integration between the tools from the mechanical side and the PCB side of things. So that's something that people could help with. Also, just spreading the word on why it's better to use free and open source software tool if your goal is to share your design. And then another thing is public institutions and universities and educational institutions. If you're in education, it would be very cool to introduce more this notion of open source hardware in universities, in high schools, in any kind of academic institution. And also if you're in a research lab, which is funded with public money, please consider introducing in whichever way you can open source, because it makes a lot of sense both for software and for hardware. And if it became the default, then that would be a really powerful thing. It would be like a snowball. It would be amazing. Mm-hmm. So I think we have some work to do on that side of things. Yeah.
Can I shout out some awesome people who are in academia doing that?
Please.
So Nadia
please do.
At the University of Washington, Jenny Malloy
awesome.
at the University of Cambridge, Julia Arancio at the University of Bath now. All of those people are doing amazing things with open source hardware in academia, and Nadia is also doing like the mechanical side of what Javier was talking about.
Mm-hmm. Oh, I'd love to have Nadia on the live stream to talk about some of that. That's pretty interesting.
And I'm sure there's like so many people I missed too.
Of course, there's a lot of people in here. Mm-hmm. Well, thank you both so much for hanging out with us here on this stream. We've learned a lot about open source hardware best practices. We've talked about how open hardware fits in with the wider push towards openness in science and data in government and so on. And we've also had a little look at some of the movements around open source that are popping up around the world. So I think we've covered quite a lot of topics for the hour that we get. thank you to everybody for joining us, and thanks for commenting and asking your questions. We've got a number of exciting streams coming up over the next few weeks, including one that I'm personally fangirling about, which is one with Bunny Huang and Zobs, who created the precursor and the Novena and like loads and loads of other really amazing open source hardware. And for that one, we're also going to be giving away a precursor, which is a very expensive piece of kit. So make sure that you like and subscribe. It's the first time I've actually remembered to say that at the end of the stream. Like, you remember to like and subscribe, like all good YouTubers say that. And we'll see you again soon with Bunny. We've got a tour of the Cyber City manufacturing plant coming up. We're going to see some proper pick and place machines in action as well. So there's all sorts of really fun things coming up on this stream, so please don't forget to like and subscribe. You can follow us on Twitter, you can subscribe to our newsletter. We never sell your data, we don't spam. In fact, we're more likely to forget to email you than we are to give you.
That's like the OSHWA motto.
Yeah. But yeah, basically, it's been really fun. Thank you so much to both of you for hanging out with us, and thanks to everybody for hanging out with us today. I will fill in a bunch of the links and add all of the amazing things that we have discussed in the stream info in the next couple of days. So thanks everyone, and see you again next time. Bye.
Bye.